I'm Jack Trinidad. So for today's video, we will tackle all about the other concepts related to plant growth. So first, what is the law of minimum? In the 19th century, the German scientist Justus von Liebig formulated the law of minimum, which states that if one of the essential plant nutrients is deficient, plant growth will be poor even when all other essential nutrients are abundant. It states that growth is controlled not by the total originality applied to plant growth, where it was found that increasing the amount of plentiful nutrients did not increase plant growth, only by increasing the amount of limiting nutrients, the most scarce, where in relation to need was the growth of the plant improved.
And we have a 6-stage Liebig's law of the minimum.
And next, the importance of micronutrients. So the law of minimum takes on added importance when fertilizer prices, especially of nitrogen and phosphate. So products are high. This may tempt some growers to reduce or even eliminate applications of micronutrients or secondary nutrients. So fertilizers such as K-Mag and a source of balance, potassium and magnesium and sulfur. But von Liebig's law tells us clearly that if a soil is deficient in says the Mg yields may be depressed regardless of how much NPK products you apply. So such a course of action doesn't make sense of any time, at any time, but can be especially ill-considered during periods of elevated prices of NPK products. Let us look in Mg or S or both, but the grower affects or elects to omit these nutrients because he or she on NPK products.
We have an example of micronutrients. First, potassium. So, nakikita natin dito sa example ng leaves na ito is meron siyang symptoms na molted, spotted, streaked, or curled leaves. And it has a scored, burned, dead leaves, and it has the margin. And second, we had nitrogen deficiency. The symptoms is stunted, older leaves or whole, plants yellowish green, and sometimes all leaves become light green and chlorotic at the tip. And also, leaves die under severe stress. And all leaves are narrow, short, erect, and lemon, yellowish green except for young leaves which are greener. And it also has an entire field may appear yellowish and reduce tillering and also reduce grain numbers. And also we have magnesium. So the symptoms of this one, it includes interveinal chlorosis, yellowing of green leaves between green veins. And it has also leaf tips, curl or cup upward, and slender and weak stems. And we have a sulfur deficiency symptoms and the manganese deficiency symptoms and also the nitrogen deficiency and also the chlorine deficiency, and the last was the phosphorus deficiency.
And next, the law of optima and limiting factors. So first, limiting factors are the factors that are not present in abundance. These are the environmental conditions or resources that limit the growth and distribution of an ecosystem. And this can be either physical or biological factors which are identified by the increase or decrease in growth or distribution of a population.
And limiting factors is something that causes population growth to decrease. A limiting factor is an environmental factor or variable that has the capacity to restrict the growth, abundance, or distribution of a population is an ecosystem. For example, limiting factors of a plant growth are the amount of available sunlight, water, and nutrients that are essential in a photosynthesis.
And next, the Blacksman law of limiting factors. So plant physiologist Laxman studied limiting factors in photosynthesis system in plants. He stated that biological factors are affected by a number of factors, but the amount in which they affect the whole process is different. Let us take example of photosynthesis. Required adequate amount of water, sunlight, chloroplast, temperature, carbon dioxide, and chlorophyll to carry out photosynthesis. The scarcity of any of these components will affect the process of photosynthesis. When the rate of the process become constant due to limiting factor, it can be regulated by regulating the amount of factor only which limited. For example, a leaf which can utilize 5 mg of CO2 per hour in photosynthesis is limited due to the CO factors. As the concentration of CO2 increased, the rate of photosynthesis is also increased. Any further increase in the CO2 concentration will not affect the rate of photosynthesis. It will only increase if the intensity of light is increased. Next, any physiological process which is affected more than one factor is governed by the law of limiting factor. The relative magnitude of factor is more important than the absolute magnitudes. And next, a factor which is present is in less quantity is the limiting factors. And next is the law of diminishing factors. So what is the law of diminishing factors? So the law of diminishing factors returns an economic principle stating that as investment in a particular area increases, the rate of profit from investment after a center point cannot continue to increase if other variables remain at a constant. And as investment continues past the point, the rate of return begins to decrease. The law states that in a production process, adding workers might initially increase output. However, at a certain point, the optimal output per worker will be reached beyond that point. Which addition workers efficiency will decrease because other factors of production remain unchanged, such as available resources. And this production process example is known especially as the law of diminishing marginal returns. It could be addressed by using technology to modernize production techniques.
So here is the law of diminishing returns.
And next, the law of diminishing returns of agriculture is a farming, the classic example of this law. The farmers usually have a range of land in which they can add an infinite number of laborers to increase crop yields. However, this is a point where an additional workers produce less of an increase in crop yields than the last worker added. At this point, the law of diminishing returns has set in, and the farm is less efficient than it was before that additional worker has employees or employed. The law of diminishing returns as the manufacturing. Other production systems follow the same logic. Adding worker past a certain number to a factory assembly line makes it less efficient because the proportional output becomes less than the labor force expansion. And next, the Enterprise Resource Planning or ERP. In ERP, it is important that organizations establish the point of diminishing returns, that is the point where per unit returns start to drop. By establishing this point, organizations can set proper expectations internally and with their customers.
This law states that as additional units of an input are used in a production process while holding all other inputs constant, the resulting increments to output or total products begin to diminish beyond some point after A in the bottom graph. As the firm uses more and more units of the variable input with the same amount of the fixed input, each additional unit of the variable inputs has less and less of the fixed input to work, and after this point, the marginal products of the variable inputs declines. As you can see as this one, productive base. At the start, every unit of input leads to the productive gains. And for diminishing returns is upon hitting the point of diminishing returns, every additional input will give you a slower gain in output. And for the negative returns, if you reach this phase, every additional input will give you negative returns.
And last, law of diminishing returns. The law of the minimum and diminishing returns are generally seen as a conflicting theories in plant mineral nutritions. Next, in this study, we show how the laws are both necessary to explain different aspects of plant response to fertilizers. And next, we apply the law of the minimum at a cellular level, determining how the limiting element is transformed into product inside plants. And also, we verify that under an uneven distribution of the limiting element and its nutritional requirements, the resulting crop models present the diminishing marginal returns being compatible with the Mead's chemist or compatible with Mead's Kernig's law. And thus, we observe that most of the crop models found in bibliography could be derived from the approach. So that's the end of my presentation. Thank you for watching, guys. Hope you listen to my presentation. Goodbye.